Okay, so find dy dx when y equals x times the square root of 3x squared plus 5. Just writing the problem down tells me a good bit. Tells me I have a product rule, really, where this is f of x and this right here is g of x. So I'm going to go ahead and in a different color, I'm going to label what f prime of x is, and that's super simple. It's 1. G prime of x, well, it may help to go back and label what g of x is and rewrite g of x as 3x squared plus 5 to the 1/2 power. You can barely tell that's one. I need to redo that. To the 1/2 power. Okay, so now when I do g prime of x, and let me move this over just a little bit. When I do g prime of x, this is a chain rule, okay, because you have something to the 1/2 power. So the something, the 3x squared plus 5 is the inside, the 1/2 power is the outside. So g prime would be 1/2 something to the negative 1/2 power. And then you would fill in the inside with your something and multiply by the derivative of that inside, which is 6x. Just to clean up g prime, 1/2 times 6x is 3x. 3x squared plus 5 to the negative 1/2. Now, I do like, now if I was just saying, hey, take the derivative of the square root of 3x squared plus 5, I would want to rewrite this and put that negative 1/2 in the denominator. But I'm not going to do that right now because I'm about to plug this into a product rule. Product rule being f times g prime plus g times f prime. So dy dx equals f, so x, times g prime. Well, that's what I just wrote. That's what I just found right here, okay? So that's 3x times 3x squared plus 5 to the negative 1/2. And look, I'm gonna, you know me, I like to put things in parentheses. I'm gonna do all that, I think. Okay, plus g, so let's just write it as the square root still if we want to. 3x squared plus 5. I don't care how you write this. I mean, you could have wrote it to the 1/2 power, okay? Times f prime is 1, so that's super simple right there. Let's clean it up. I'm going to say this is 3x squared over the square root of 3x squared plus 5 plus the square root of 3x squared plus 5. Okay, well, normally I would end here normally, okay, but problem that we have with this question, let me show you the problem for just a second, is this, right? It's multiple choice. That's not one of our choices. So looks like what they have is see what I just had was a fraction plus a number. They either, everything that they have is either just one fraction or no fraction at all. Okay, so let's get this thing into one fraction, and we're going to have to do that by let's see, how can I move this out of the way? Wait just a second. So I'm going to find a common denominator. This one's denominator is 1. This one's denominator is obviously 3x squared plus 5. What I'm going to do, the common denominator is going to be 1 times 3x squared, the square root of 3x squared plus 5, which is just the square root of 3x squared plus 5. That's going to be the common. And to do that, see, this fraction right here already has a denominator of the square root of 3x squared plus 5. So I'm just going to write its numerator down. I don't need to do anything to its numerator. But this fraction does not have a denominator of 3x squared plus 5. So what I can do is multiply it by the square root of 3x squared plus 5 over the square root of 3x squared plus 5. And when you do that, you're multiplying it by 1. Okay? Well, the square root of 3x squared plus 5 times the square root of 3x squared plus 5, see, that's the same thing. And it's a root times a root. So when you multiply that thing out, it just gets rid of the square root, basically. So it's 3x squared plus 5, and there's no more root. It's actually quite nice. And you have like terms in the top, and it's 6x squared plus 5 over the square root of 3x squared plus 5. Okay, and so what I saw from the question is that everything was one fraction. So hopefully, now I have one fraction. Hopefully this is a answer, and it is option C. Exactly what we got.